Welcome to a first part of a Fusion tutorial series. This series is kind of aimed at knife makers, but not really professionals, more like people who want to modify a knife, want to put different scales on it or anything. Was asked to do something like this by a couple of friends and good customers and decided, okay, now's the time to get started. I'm choosing Fusion 360 as a software. Well, I think nowadays it's called just Autodesk Fusion because there's actually a free hobbyist license which should do most of what you're trying to achieve. Nevertheless, my Fusion might look a little bit different than yours because I'm running a commercial license of Fusion, so I have a lot of features that are not in the free version. I don't think we are going to use those features, so bear with me. First, to give you a small sense of what this episode will be about, it will be about copying, or not really copying because we're not copycats, but about getting the design, for example, of a handle in order to then start modifying it. Now, the best way I think to do this is still by doing it manually. In Fusion, you have the option to insert what is called a canvas. And you find this one in the upper menu bar under Insert. When you go on Insert, you can click Canvas, and Canvas lets you place an image on a planar face. And then we can later draw on this one. Now, if you click on that, it opens a dialog where you can say Insert from my computer. You can then choose on your computer a picture. I already chose a picture once here, and we click on Open. Now, Fusion then wants you to select the plane where you want this picture to lie flat on. This is a little bit arbitrary. I personally enjoy having it on the X and Y axis plane, so I'm gonna select that one, but you can basically choose any one. Now, once you have placed that picture, there is a couple of options you want to do. The first one is in the menu to select the canvas opacity around a value of 50%. This will make it so that the canvas is actually slightly transparent when you are drawing something, especially behind the canvas, which later when we do a 3-body will become a thing. You can still see through this. This is very, very helpful. You can also scale it. You can do horizontal or vertical flips. You can scale it with the mouse buttons, but we're later going to do an exact scaling to get the physical dimensions right. You can just place this here, and by clicking on OK, the picture becomes fixed to this plane. Maybe let's talk for a short moment about the picture. What you can see here is a cassé knife. It's a production series done by Linda or Shard, and this one doesn't have a handle. So I thought for today's lesson, we would look into how would I design a handle for this knife, and we will start by copying the plate shape. Now, if you take such a picture, it's a good idea to make sure that your camera, for example your phone, is mostly exactly vertical and parallel above the object you want to photograph. Moreover, you should also put something into the picture which has some known distance on it. You can see here I put a metal ruler into the picture. It could also be a coin. You could even scale the picture based on a known size. So for example, with a pair of micrometers, measure one of these holes or something. I find the linear scale in the picture to be the best version. One word of caution here, most modern phones have wide-angle lenses, and these wide-angle lenses, even though there's a digital compensation, distort the picture a little bit. If your phone has several lenses, it's a very good idea to select the telephoto, the zoom lens, but not the the digital zoom. It should be an optical zoom, as those show less distortions. Now, we still need to do one step before we can get started on drawing, and that one step is we need to define or calibrate the size. And in your object browser on the left side of the screen, you now have a folder called Canvases. And if you click on the little arrow, your image actually pops out. If you put a right click on this one, there's the option to calibrate the image. Now, if you hit calibrate, it first looks like nothing is happening, but you need to select 2 points now. And if you actually stay with the mouse there, it also tells you in the tooltip. What I'm going to do now is I'm basically selecting, and I'm just zooming in for this, selecting the first point on this scale. And now I'm moving out and selecting a second point. This gets more precise the further apart the 2 points are, and then it doesn't matter as much where on the pixels you are clicking. Now Fusion wants me to tell it what this distance is. And well, this is a metric ruler, obviously. It is a distance of 100 millimeters. By pressing enter, you can then register that length. At this point, I typically advise people when they start with a sketch to do a quick sanity check whether this calibration has actually worked. And you can redo this as often as you want by just hitting calibrate on it. Now, most CAD software works the same way, and the way is always you start in 2D, you draw a 2D sketch, and from that sketch onwards, you construct your 3D body. In Fusion, you can create a sketch by clicking Create and then Create Sketch, or just hitting the Create Sketch button in the toolbar. Now it's important that you select the same plane as the object is on. And now we can actually start. First with a sanity check. For this, I'm going to select the line tool and draw a line on the ruler and see whether the distance matches up. So here with our first point, and this should be around about 20 millimeters, and that's not too bad. You can see 20 millimeters. So this is a good sanity check, and we can now delete this one. If we now want to draw the handle shape of that knife, I would typically advise to start with the simple shapes. Simple shapes are, for example, a primitive like a diameter circle. In the Create menu, you have an option for several different circles. You can, for example, and this is if you're copying something, a nice choice, choose the 3-point circle. There you just place 3 points on that circle, and Fusion automatically creates a circle. You can move this circle just by clicking and dragging, and you can make sure it lines up perfectly with the hole. And of course, if you click on the outside and move the outside, you can also still modify this one. Now, most often these holes, especially if it's like a production knife, have a certain size. And if you want to know the diameter of this circle, you can either click measure on it, and it now tells you, okay, this is a radius of 4.16 millimeters. But often standard tooling is used and they have like a set size. So something you could also do is use the dimension tool, which is called sketch dimension. You can find it on Create, sketch dimension. You click on that circle, place the dimension symbol to the right side, and you could now, for example, say, hey, this should be 4.15, because I'm quite sure no one in Europe is going to drill a 4.16 millimeter hole. It's probably a 4.15 millimeter hole. We have our first hole. Let's do the other ones. The short key for a center diameter circle, for example, is the button C, which I'm placing now here. And this one actually looks like a 4 millimeter hole. And we have a hole in the back. So I'm placing another center diameter circle. And now you can also see why I tell you it's important that you take the photo as vertical as possible. If you have a flatbed scanner, this is even better. Flatbed scanners give you a totally perpendicular view of the object. Just make sure you don't scratch your scanner. Okay, let's give this one also some dimension. This is probably 8.35, maybe. Now, these are the simple contours on this. All other shapes here are freeform shaped. It's not super difficult to copy a freeform shape, and I'm going to show you. The tool we are using for this one is called a spline tool. You find it under spline, and there's two different splines. The fit point spline, which is the one we need, and there's also a control point spline. With the fit point spline, the typical approach is you start at a sharp corner, and whenever you do modeling with a fit point spline, the rule is, it's called KISS, keep it simple and stupid. And then as you go along, you add details. The way the spline tool works best is Every time your curvature changes drastically, you place 1 point. So when we are starting here at the bevel of the plate, now the first drastic change in curvature is pretty much here in this corner. The next one over here where it actually changes direction. I'm now just clicking every time it changes direction, or it changes, yeah, the curvature a lot. So you can see I'm adding 2 down here, and then probably a single one up here. If you press on the little arrow that appears every time after you set a point, it will close that spline, close it in terms of this will now exist as a curve. If you hit escape, it will actually cancel the spline. So you have to click this little green arrow here. Now, I'm pressing on the keyboard, I'm pressing once escape as a button, and now I'm back to just the regular mouse tool. You can see this outline, it's kind of following along, but not yet perfect. If you click back on the spline, this spline tool, and this is one of the properties in like every CAD software ever, how spline tools work, they have these handlebars, and these handlebars, you can change the angle of them, and you can now see the curvature is actually changing, but you can also change the distance around the spline fit point. And with that one, you can actually adjust the curvature. And you can see just by moving this around, and this requires a little bit of practice, and this is also one of the reasons why you should do very, very few points in the beginning, you can actually adapt to the shape or the outline of that handle. So now I'm just going along on every point, changing the curvature a little bit, changing the bearing of these. And this is also an iterative process. So you should go back and forth with everything to make sure you're hitting the outline as good as possible. Don't spend too long on a single point, because as you can see, it also always influences the other spline fit points. So now I'm going back to the first one, adjusting the radius a little bit here, going back to the second. Now, sometimes you will see that it's kind of not possible to perfectly hit the curvature. A good option is then to actually move the spline point, because then the spline behaves a little bit differently. And if you're really, really struggling because it's a very complex shape, you can do a right click, and then you can say insert spline fit point. And then once again, kind of every menu disappears, but you just select a point somewhere along that spline, and it will add a new point there. It's important to hit escape now, because otherwise you're just going to add points over points over points. Now I can move this point again, and also it once again got handles. I can try to adapt the shape better to what it should look like. The problem here is, of course, you are getting small amount of unsteadiness into this one. So your curvature might not be a perfect fit anymore. This could be a problem. As I said, keep it simple, stupid is typically the best approach. Okay. If you ever want to delete one of these spline fit points, because I don't feel like this one is working out, you can just select it and then hit the delete key, and it will delete that spline fit point. Okay, at this point I'm quite happy with how the handle looks like. If you have tiny gaps such as this one, it often helps to remember how much the deviation is. So it's probably just a couple of tenths in that way, and honestly, you will have to do some hand sanding as well. You can continue doing this as long as you want. At some point, it probably makes sense to just stop and decide, okay, some minor hand sanding is needed. If I had to choose, I would suggest that you try to always stay outside the handle contour, because as always with subtractive manufacturing, you kind of can't add material to it in a nice way. So it's better to stay outside and then just do a little bit of hand sanding than actually go on the inside. I don't think we need to do this recess here. That would be another thing you could do if you want to have the whole full handle. For like adding scales to this knife, I don't think it's really important. So we're going to basically stop here. The only thing we need to do to actually make it a knife blade shape is to add the spline up here. And the reason we didn't do one single full closed spline at this point is, well, splines are really difficult to give, or it's really difficult to give splines a sharp endpoint, except if you add a second spline. So now we're going to again use the spline tool. So going to the menu, spline, fit point spline, and just add one at the points of the spline we had before. Just 2 is enough, hitting that little marker arrow. And this spline you can now adjust independent of the other spline and just fit it to the curvature of the plate. There you have it, close enough for what we want to do. Now, if you want to create a 3D body from this, what you can do is hit Finish Sketch. And now you have a closed sketch outline. And if this one doesn't turn blue, it means you didn't hit the spline handle points beforehand. This one can now be converted into, let's say, a 3D solid body by using the extrude tool. So you click on create and then extrude, and you can define a thickness. Let's say this is 3.15 millimeters. I actually did not measure, but it doesn't really matter. And now you can also see why I turned on the opacity control in the beginning, because we are still seeing our canvas, and at the same time we can still see our 3D body. And this is actually a really decent fit already. Now, if you want to add some scales to this knife, now you can just use this as a regular CAD software. Just gonna quickly talk you through this. If you're using a Fusion Hybrid design, you could just say new component, but I'm not sure whether that is available in the free version. So we're just gonna stay with bodies. What I'm gonna do next is, you might have guessed it, exactly another sketch. I'm creating a sketch just on top of this knife. Trying to decide where I want the handle to end, probably somewhere here. I'm using the spline tool to give it a slight amount of curvature here, because that might look nice. And then it's again Finish Sketch, clicking on the extrude functionality. And now I'm extruding the handle out. You can either go by measurements or just by optical view, like what you would say would be nice. I'm going for 5 millimeters. Important here is now don't do join as an operation, because this will fuse the two together. Actually click on new body. Now, maybe you want to screw the handle together, so this would be a good moment to add recesses for the holes. You can once again do this by creating a sketch using the center diameter circle tool. Let's say, for example, your screws are 8.5 millimeters. Then clicking Finish Sketch, using Extrude again, but this time in the cut functionality. So we're just going to do a counterbore of 3 millimeters here. And then you can start modifying this shape in any way you want. So for example, giving the handle a nice rounding around the outside. For this, I'm selecting Modify and the Fillet tool. Clicking on the contour I want to fillet, and now doing, for example, a fillet of 5 millimeters, or because this would give you a very sharp corner here, maybe it would be better to do 4 millimeters. This is basically the point where you have the most difficult part done. You now have the geometry there, and you can start modifying or modeling the handle in a way you think it should look like. Okay. I think that's enough for the first lesson. I'm not really willing to show how to use Fusion for overall modeling besides what you needed here. There's tons of very good tutorials out there. Thank you so much for watching. In the next episode, we're going to take a look on how to program it in the CAM module.